Okay, so after this a break, we'll start the class now. So moles of CO2 is 0.95 kg moles and moles of CaO is 0.95 kg moles because 1 mole to 1 mole, that is there. So let us write the material balance now at the so what is entering? So M, I will take this as M and this as Z. So recycle will take it as a Z. So what is material balance I can write if okay M is so M is equal to X plus Z. So of overall material balance. So the CO2 balance, component CO2 balance at the point A. So what you can write here, CO2, how much is the CO2? 0.07 is equal to 0.05x plus 0.05x plus 865Z, because the composition won't change. Only the recycle stream which is coming here, that it is being taken. So the concentration of CO2 won't change there. That's why I have taken 0.0865Z. Okay. Now, using equation 1, so here X plus Z is 0.07 . So if you solve this, Z is equal to 1.212x. So this is what we have written at the point A. Now amount of CO2, this is the component balance at the point A, means entering. Amount of point A entering the clean here. Okay. Now component CO2 balance, component CO2 balance at clean. So how much it is entering? 0.07 M it is entering, plus this is entering 0.07 CO2 is entering with M. Okay, in M it is there. And from clean how much it is entering? 0.95 kg moles. Okay, so 0.95, this is entering the clean. What is leaving the clean? The leaving the clean is 0.0865y. Okay, 0.8006y. This is another balance we are writing. So amount of N2, because this is only the inert substance which is entering and leaving. So amount of N2 entering and leaving conditions. entering and leaving conditions. So x into 0.95, because 5% is CO2 means 95% is the in air. In air, 95% we take it as the nitrogen which is entering, is equal to y minus z 0.9135. So x into 0.95, otherwise you can put not here so that it will clear. X into 0.95 is equal to y minus, substitute the z here, 1.212x into 0.135. Okay, so you can get the relation in terms of y. So y is equal to 2.25195x. So here x plus z into 0.07, x plus z into 0.07 plus 0.95, this is what we are writing. Okay, this equation. So you can number that equation as 3. So write down using equation 3. Using equation 3, m can be written as x plus z 0.07 plus 0.95 is equal to 0.865y. But we know the relationship between y and x. So here you can write down like x plus 1.212x 0.07 plus 0.95 is equal to 0.86y, and x plus 1.212x into 0.07 plus 0.95 is equal to 0.865 into this one, using equation 4, 2.25195. So you will be getting x as, if you solve this, you will be getting x as 23.29 moles. 23.29 moles, and z is equal to, what is z is equal to? Okay, we have the relation between the z and x. Okay, what is the z? 1.2, 1. Z is equal to 1.212 into 23.29 will give you 28.2275. Okay, that is Z. X, in that you will be getting Y, 52.4025 moles. These are all streams, so moles. So we have to check it whether I have done correct or not. So what I'll do is X. So Z plus 0.95. Y is equal to x plus z plus 0.95. So y is equal to 52.45. See, the same y I got. So calculations are correct. Because if you do the material balance, it has to, because this y is the moles which are coming in, it is a combination of m. M is nothing but x plus z plus 0.95 of CO2 which is entering here. So total will be y is 52.45 moles. Now he has asked me the another question here, that is the amount of coke. So amount of coke, C plus O2 gives CO2. Amount of coke, C plus O2 gives CO2. So amount of carbon, amount of carbon. Anything given regarding the coke here? So heat from the reaction is supplied from a furnace burning powdered coke, which is essentially pure carbon. The hot flue gases and all. So, right. So how can we get CO2 here? Because see, from here I can get the amount of CO2. With that I can get that. So the amount. See, the amount of CO2 coming out of furnace, correct? Coming out of furnace. How much it is? X into 0.05. That is nothing but X into 0.05. So, I know X. X is 23.29 into 0.05. So how much is that is 1.1645 moles of carbon dioxide. Okay, using the equation 4 here. Now 1 mole to 1 mole, correct? So the amount of carbon, the amount of coke or amount of carbon, because coke is completely carbon, that is nothing but 1.1645 moles, but amount, generally amount means in kgs, amount of coke in kgs generally, because this is only our calculation. Moles is our language, okay, not the general language. General language is kgs. Only for our calculations we will do this. So moles, amount of coke in kgs is 1.1645, because carbon molecular weight is 12, so hence it is 14 kgs. So what is the recycle ratio? Recycle ratio is Z by Y. So this is another answer, 14 kgs. And recycle ratio is Z by Y. Z is 28.2275 by 52.4025. That is 0.54. So recycle ratio is 0.54. Is the answer. See how we have done. We have balanced at each and every point, this point, and finally we have taken the the key in this particular problems, I told you that for any material balance, first you have to search for the inert materials, tie materials, or you have to solve by simultaneous equations. Because what I am writing here is completely on carbon dioxide, so I will be getting in a form of simultaneous equations. But to get that particular stream amount, we have to take advantage of the inert. What are inerts here? Nitrogen is an inert. So if you balance the nitrogen, that is what we have done. So I got the one stream. Once I got the one stream, automatically other streams amounts I will be getting it. So that is the key of that. Okay. Right. So this is a beautiful problem. You go on practicing this. That once again I am telling you, there is no hard and fast rule that you have to follow the same procedure. But with my experience, I have done this, and if you can also, you can reduce the, while practicing, you just practice with my idea, and then you can have your own ideas to solve. You may also reduce the number of steps required. Okay, that will be highly appreciated. So these are classical problems I am giving to you. If you go on practicing, then it will be very simple for you to solve the gate problems. Because the gate problems will not be this complicated. So let us solve another very interesting problems. Stock containing 1.562 grams of water per gram of dry stock is to be dried to 0.0999 grams is to be dried to 0.009 grams for each gram of stock dry basis 52.5 grams of dry air passes through the dryer leaving at a humidity of 0.0525. The fresh air is supplied at a humidity 0.0152. Calculate the fraction of dry air recirculated. Stock containing 1.562 grams of water per gram of dry stock is to be dried 2.099 grams. For each gram of stock on dry basis, 52.5 grams of dry air passes through the dryer, leaving at a humidity of 0.0525. The fresh air is supplied at a humidity of humidity 0.012. Calculate the fraction of dry air recycled. So this is another wonderful problem. So it is a dry air here. Here also it has not given, so we have to draw the diagram so that you understand. Here the dry air is there, is introduced and we get the dry solid here. Okay, we'll get the dry solid. About the wet solid, stock containing 1.62 grams of water per gram of dry stock. So he has given us a stock that is grams of water per gram of dry stock. Then, okay, this is X1 because it's an amount of the water per dry stock. So X2 is to be dried to 0.099. So he has given us how much the amount of water, because dry stock won't go, amount of water to be removed. For that, what is using? For that is using a inlet air. Inlet air means what? Humidity. So because we can't send the dry air, so what we do is we take the humidified air. So he is taking through the dry air 52.5 grams of dry air passes through the dry air, leaving at a humidity of 0.0525. So the inlet air for each gram of stock on dry basis, 52.5 grams of dry air passes through the dry air, leaving at a humidity of 0.0525. So 52.5 grams of dry air. (52 grams of dry air). The fresh air is supplied at a humidity of 0.0152. So inlet air humidity is Y1 is 0.0152. In 0.0152 we have 52.5 grams, because this is the humidity ratio, is the ratio of the amount of water vapor by amount of dry air. Okay, so this is Y1 is 0.152, and after leaving the dry air, he has given through the dry air a humidity of 0.0525. This is Y2. Okay, the fresh air is applied through the dry air, leaving it humidity. Calculate the fraction of dry air recycled. So again, there is a recycling process which is happening here. Recycling here. So they will take some part here and recycle. So they want to know what is this recycle ratio. Are you clear now? So we have developed our own flow sheet here, depend upon the conditions given. So basis is 1 gram dry stock. Basis is 1 gram dry stock. Gram generally we define, for your understanding I am writing that, but generally for SI units we have to G. Okay, but for your understanding, gram like this. Okay, generally we should not write GRM, we should write only G. Okay, anyway, for your understanding. Right. Now, the amount of water removed by the dryer. Okay, so what is happening here? Let us see the amount of water removed by the dryer. Correct? Removed by the dryer. The amount of water removed by the dryer is how much? X1 minus X2. Correct? Because X1 is the wet solid, X2 is the dry solid. So X1 minus X2 is 1 point, X1 is 1.562 minus 0.099, that is 1.463. 1.463. This is the amount of water which is been removed. Okay. Amount of water which is removed. So here so this water is being right. So what is the okay, right. Now let us write down the so that is the amount of water has been removed. Yes. So now for each gram of dry stock, 52.5 grams of dry air passes through the dryer. So now what is an amount of water here? 1.463. So what is the humidity? What is the humidity there? Y2. The humidity Y2 is 1 point. So amount of water is being removed. So what is going? It is, let us say it is, this one is Y3, let us say Y2. What is Y2? The amount of humidity, not amount, the humidity what is it? Humidity developed. Okay, humidity developed in the dryer. Humidity developed in the dryer. So Y2 is equal to 1. So that will give you 0.02787. 0.02787 grams of water by grams of dry air. So let S be the amount of dry air recycled. Amount of dry air recycled. S be the amount at point A. So S plus 52.5 will be M. Okay, this is leaving here. This is M. S, let us write S here. S is the amount of the dry air. 52.5 is equal to M. So let us do the moisture balance. Moisture balance A. What is the moisture balance at A? S into 0.0525. S into 0.0525 because this is coming out. Okay, so only the what is there is recycled, but 0.0525 will remain the same. This is an amount is equal to plus 0.0152 into 52.5. 52.5 is equal to M into Y3, because we don't know that how much the has been circulated. So this is, we take it as we call this as a Y1 in, okay, Y4 you can write down. So Y4. Okay, but this Y4 is what? What is this Y4? The Y4 is 0.0525 minus 0.0278. 0.0278. Right, 0.0278. This one. 0.0278. So S into 0.0525 plus equal to S plus 52.5, that is M, into 0.0255. So if you solve for S is equal to 49.55. So the fraction of recycled dry air Okay, so like this we can also solve some problems here on the humidity. Okay, so these three problems are the classical problems for you to solve. It will give you a practice to solve the problems. Right. Okay. So let us solve the GATE 2011. Ammonia is synthesized. Ammonia is synthesized at 200 bar and 773 Kelvin by the reaction N2 plus 3H2 is 2NH3. The yield of ammonia is 0.45 moles per mole of fresh solid, per mole of fresh feed. Flow sheet for the process. Flow sheet for the process along with available compositions is shown below. So he has taken the reactor, then separator, pure ammonia, This is the fresh feed, 75 mole percent A, 24 mole percent N2 and 1 mole percent inerts. 1 mole percent inerts, and this is the recycle and purge stream. This is recycle 75 mole percent H2, 15 mole percent N2, 10 mole percent inerts. 10 mole percent inerts. The single pass conversion. The single pass conversion for H2. The single pass conversion for H2 in the reactor is 20%. The amount of H2 lost in the purge as a percentage of H2 in fresh feed is A 10%, B 20%, C 45%, D 55%. Ammonia is synthesized at 200 bar and 773 Kelvin by the reaction N2 plus 3H2 gives 2HN3. The yield of ammonia is 0.45 moles per mole of fresh feed. Flow sheet for the process along with available compositions is shown below. Okay. The single pass conversion for H2 in the reactor is 20%. The amount of H2 lost in the purge as percentage of H2 in fresh feed is 10%, 20%, 45% and 55%. So how to proceed? Okay, ammonia is synthesized at 200 bar in 773 Kelvin by the reaction. N2 plus 3S2 gives, the yield, this is said that only a single pass. The single pass conversion for S2 in the reactor is 20%. The amount of S2 lost in the purge as a percentage of S2 in the fresh feed is. Okay, he has given the fresh feed. So let us write down what is happening in the reactor. Solution N2 plus 3H2. N2 plus 3H2 will give you 2 NS3. So assuming, because he has given it, assuming fresh feed of 100 moles, then yield of ammonia is how much? 0.45 moles per mole of fresh feed. So 0.45 moles per mole of fresh feed. So how much? It is 45 moles, because for 0.45 moles for 1 mole. So for 100 moles it is 45. So moles of NS3 formed. Moles of NS3 formed is 45 moles. Okay. Moles of NS3 formed is 45 moles. Now, moles of H2 required. See, moles of H2 required from the theoretical equation. How much? NS 45. This is 3 by 2. Okay. So 3 moles of H2 to 2 moles of NS3. So it is 45. 45 is what? 45 moles of NS3 formed into 3 by 2. 45 into 3 by 2 is 67.5 moles. So we got H2. How much H2 has generated? Now, what he has given? Single pass conversion he has given. Single pass conversion. Pass conversion. Single pass conversion is 20%. That's what is given. Single pass conversion is 20%. Yes, here he has given 20%. So if single pass conversion is 20%, then moles of H2 entering the reactor. Moles of H2 entering the reactor. Moles of H2 entering the reactor moles of H2 entering the reactor is by 0.2, that is 337.5 moles. Okay, so that is the moles of H2 entering. The reactor is 67.5 O2, 0.2, 337. Now, moles of H2 coming out of the separator, is 337.5 minus 67.5. 337.5 minus 67. Will be 270 moles. Okay. So, moles of H2 in fresh feed is 75. So, this is basis. The mole of H2 in recycle. Moles of H2 in recycle is 337.5 minus 75 will be 262.5. Then moles of H2 in purge. That is 7.5. Thus, the amount of H2 in the purge (10%). Thus, the amount of H2 lost in the purge is 7.5 by 75 into 100, that is 10%. So, the answer is A. The answer is A. Okay. Right. So, this is the way I have solved the problem. GATE 2011. So, moles of NH3 formed is 45 moles, because I want to get it how much from the yield of ammonia, how much the hydrogen is formed there. Then moles of H2 required from the theoretical equation is 67.5%. Okay, but the 67.5 moles has been generated with only 20% conversion. If it is 20% conversion, then only 67.5 moles have been generated. Okay, but so actual moles of H2 entering the reactor here, this place, at this place is 337.5 moles. So the moles of H2 coming out of the separator, 337 that is 270 moles of H2 in that. So all the things are calculated. Finally, the answer is 10. So this all ideas will come once you solve this 3 classical problems what I have given to you. Okay, right. So now, yes, the questionnaire time for us.